In problem 25 from our textbook, we are going to do a more involved computation, and we want to compute the real and imaginary parts of this sort of more complicated product of complex numbers. So z here is I over 3i, whatever that is, times 1 over 2 plus 3i, whatever that is. And then we want to compute that product and then take the real and imaginary parts. And we're actually not going to do that order. The easiest way, I think, to go, I mean, this depends on the problem, but in this case, I think the easiest way to go about this problem is to first multiply our fractions and then divide the corresponding expression. So that's what we're going to do. So z itself is this I over 3 minus I times 1 over 2 plus 3i. We're going to multiply the numerator and the denominator. And we get, of course, just that, I over 3 minus I times 2 plus 3i. And now let's multiply out our denominator by FOILing. 3 times 2 is, I'm going to skip some steps here. 3 times 2 is 6. 3 times 3i is 9i. Negative I times 2 is negative 2i. And negative I times 3i, well, let's be a little bit careful here. We'll write that one out. So we get 6, combine these middle two terms to get a plus 7i, and then negative, this is going to negative 3i squared. And remember, I squared is negative 1, so this is actually going to be 6 plus 7i plus 3 in the denominator. So we can write z as this, I over 9 plus 7i. 6 plus 3 is 9, of course. And now that we have computed that, we are then going to divide these. We're going to do this division here. And the method for doing division is, of course, multiplying by the conjugate divided by the conjugate, which is a careful choice of 1. And I'm going to scroll down quite a bit now. We multiply the numerators, so I times 9 minus 7i. We'll do that product in a second. And we saw that when we multiplied conjugate expressions, you get the square of the real part plus the square of the imaginary part. And it doesn't matter which one you think of as the imaginary part, 7 or negative 7. Both of them squared to the same number. I times 9 is 9i. I times negative 7 is negative 7i squared. Again, our I squared is like a negative 1. And then 9 squared is 81, and 7 squared is 49. So it looks like in the numerator we have negative 7 times negative 1 is positive 7, and a positive 9i. In the denominator we have 81 plus 49, which I believe is 130. So as a complex number, we now have to learn that z is 7 over 130 plus 9 over 130i. Now, sometimes we do a long computation and we've scrolled away from what the actual problem was and we've forgotten the problem. So let's go remind ourselves what the actual question was. Oops. The question was to compute the real part of z and the imaginary part of z. So now that we have an understanding of what z is, we know then that the real part of z is the guy without the I, and the imaginary part of z is the coefficient of I. It's coefficient of I. Whenever you're computing the imaginary part, there should never, ever, ever be an I attached to it. It's just the number on I, the coefficient of I. So in particular, it is not 9 over 130i, so don't make that mistake. All right, so we've concluded here the real part is 7 over 130, and the imaginary part is 9 over 130. This is a little bit more of a more complicated arithmetic problem, but we persevered.